Bosons and fermions are two fundamental types of particles in quantum mechanics. Bosons have integer spin, while fermions have half-integer spin. Spin is a quantum number associated with the rotation of a particle. Bosons. 1. Properties. Integer spin. Can occupy the same state multiple times. Follow Bose-Einstein statistics. 2. Examples. Photons. Neutrinos. Higgs boson. W bosons. Z bosons. Fermions. 1. Properties. Half-integer spin. Cannot occupy the same state more than once. Follow Fermi-Dirac statistics. 2. Examples. Charged leptons. Quarks. Protons. Neutrons. Differences between bosons and fermions. The main differences between bosons and fermions are as follows. Bosons and fermions play very important roles in quantum mechanics. Bosons are used to explain natural phenomena such as light. Fermions are the fundamental particles that make up matter. Examples of bosons and fermions. 1. Bosons. Photons. Quanta of light. Neutrinos. Very light particles. Higgs boson. Particle that gives mass. W bosons. Mediate weak interactions. Z bosons. Mediate weak interactions. 2. Fermions. Charged leptons. Particles that interact with all three fundamental forces: electromagnetic, weak, and gravitational. Quarks. Particles that make up the nucleus of an atom. Protons. Particles made up of 3 quarks. Neutrons. Particles made up of 3 quarks. When do bosons and fermions occur? Are they only created when particles collide in an accelerator? Do they exist in the beginning and disappear? Bosons and fermions have existed since the moment the universe was born. The early universe was very hot and dense, so all particles were very close to each other. Therefore, the distinction between bosons and fermions was meaningless at this time. As the universe expanded, the temperature cooled and the density decreased. As a result, bosons and fermions began to separate. Bosons can exist in the same state multiple times, so they can exist freely in space. On the other hand, fermions cannot exist in the same state more than once, so they form complex particles such as atoms and molecules. Bosons and fermions can also be created when particles collide in an accelerator. When particles are collided at high energies in an accelerator, new particles can be created from that energy. These particles can include both bosons and fermions. Therefore, bosons and fermions have existed since the moment the universe was born, and they are still found all over the universe. To be more specific, bosons and fermions can be created in the following situations. 1. Early universe. In the early universe, all particles had very high energies. At this time, the distinction between bosons and fermions was meaningless. As the universe expanded, the temperature cooled and the density decreased, and bosons and fermions began to separate. 1. Accelerators. When particles are collided at high energies in an accelerator, new particles can be created from that energy. These particles can include both bosons and fermions. 1. Decays in nature. Some particles can decay into other particles. In this case, the decayed particle can be a boson or a fermion. 1. Supernova explosions. Supernova explosions are one of the most powerful explosions in the universe. Many particles can be created in the process of a supernova explosion. These particles can include both bosons and fermions. 1. Cosmic rays. Cosmic rays are a stream of particles that fly from space to Earth. Cosmic rays can include both bosons and fermions. In conclusion, bosons and fermions are not created solely in particle accelerators. They can be created in a variety of situations, including the early universe, decays in nature, supernova explosions, and cosmic rays. What does it mean for a particle to have an integer or half-integer spin? Spin is a quantum number associated with the rotation of a particle. In general, particles can have either integer or half-integer spin. Integer spin. Particles with integer spin can exist in the same state multiple times. For example, photons and neutrinos have integer spin. Photons are the quanta of light, and neutrinos are very light particles. Half-integer spin. Particles with half-integer spin can exist in the same state 2 or fewer times. For example, electrons have half-integer spin. Electrons are the particles that orbit the nucleus of an atom. An easy way to understand the difference. We can think of particles with integer spin as chairs. Chairs can be placed in the same direction multiple times. On the other hand, Particles with half-integer spin are like chairs that, if rotated 90 degrees, are facing a different direction. Therefore, two or more chairs cannot be placed in the same direction. Examples. Here are some examples of particles with integer or half-integer spin. Spin. Particle. Integer. Photons, neutrinos, Higgs bosons, W bosons, Z bosons. Half-integer. Electrons, quarks, protons, neutrons. This difference in spin affects the quantum mechanical properties of particles. For example, bosons can exist in the same state multiple times, so they do not repel each other. On the other hand, fermions cannot exist in the same state two or more times, so they do repel each other. These properties play an important role in understanding the interactions of matter and energy. Additional information. The spin of a particle is quantized, which means that it can only have certain values. The spin of a particle is determined by its internal structure. For example, the spin of an electron is 1/2 because it is a fundamental particle. The spin of a photon is 1 because it is a composite particle made up of two photons.